All right, good morning. Hopefully we're in the room to hear about Kubernetes, or how, more specifically, maybe we don't need to care about Kubernetes so much. If you're not here for that, please stay. It's better than anything else we've got going on over there. So my name's Todd Whitehead. I'm a cloud solution architect at Microsoft, and I focus on app innovation. So that means basically anything fun, right? I don't want to keep your infrastructure, keep your data. I'm really interested in how we build apps. I'm not sure how many got to the keynote, Richard Campbell's keynote yesterday. We had a quote that I love, which is about the, history doesn't repeat itself, but it does rhyme. And I started to think about this, and I kind of went back. So this was the very first website I ever built, commercially, like paid for. Isn't it awesome? Don't you love the late 90s? Nothing you couldn't do with table layout and image maps, I swear. But this website actually holds a few dark secrets. Two of them I'll tell you now. One of them maybe is more of a beer conversation later on. So the first is, this was a time when you could convince your manager that your dev web server, there was only one option for that, a $50,000 Silicon Graphics workstation. How could we get away with that? Well, first of all, managers in those days didn't know a lot about what you needed for web development. And we specifically wanted this one because it was the one they used in Jurassic Park, and it had that awesome file explorer. But the reason we could get away with it is because code was written like this. It was written in CGI. Does anyone ever write CGI? Yeah. Not the cool CGI, which is what our manager thought we meant. So when he went to the Silicon Graphics workshop, it said it was ideal for CGI. That's how we got away with it. Common gateway interface. So this is the way websites used to be built. This was the first attempt at dynamic websites. So it's basically a whole lot of print statements with your HTML code hidden inside. So you can imagine how many hours and hours were spent trying to get those strings inside strings just right. It worked. It wasn't super productive. As a developer, it was really annoying because you had to flip between two worlds. You basically had to design your web page, and then you had to go and wrap it in this whole other thing to actually get it to work. What does that remind me of? Can't remember. But fast forward to 2022, and the world looks a lot better, right? We got DevOps, we got microservices, we got containers, we got APIs, we got serverless, we got all this great stuff. But despite all that progress away from our printf statements, we're still being challenged with probably the same things, right? That's awesome, but I need you to deliver more value. I need to make sure it's reliable, I need to make sure it's fast, and I need to make sure it's scalable. Okay, that's awesome. So how do we do that? So regardless of what the tools are, these are some of the key things we often do as developers, right? It's actually about what we don't do, right? What we want to minimize. We want to minimize complexity. We want to minimize responsibility, particularly as developers. So that means handing off as much as we can to something else. And that doesn't mean a person. These days in cloud land, that probably means a platform, right? One of the other things I used to do whenever I built my websites was write a bit of SQL script that said, create table user. Because you did your own identity management. You wouldn't dream of doing that now, right? We have these great identity platforms like Azure Active Directory, Auth0, all that kind of good stuff. Why on earth would you write that? There's a whole lot of things we want to do. So when we build modern apps, we build cloud native apps. How do we do it? Well, we could take something like this. This is just one of the Microsoft reference architectures, and looks good. It's got serverless, it's got API management, everything does its bit. We've got some Azure Active Directory, good to go. Well, it is, and plenty of websites have been built this way. But there's actually a lot missing in here, right? These pieces are all deployed individually. For example, we've got a whole lot of function apps. They might have their own URLs. So whenever anything changes, we need to manage that. We need to wrap a layer around this. There's a whole bunch of cross-cutting concerns we need to do. How do we deploy a new version of this app? Well, maybe it involves a storage, maybe it involves a function, maybe it involves some changes. We need to orchestrate that process. And being 2022, what do you think of as soon as I say orchestrate? Yeah. Doesn't really matter what the question is. We all know Kubernetes is the answer. Now, Kubernetes is awesome. I'm not going to bash Kubernetes at all. It is awesome, but it's also complex. Who's deployed Kubernetes? Awesome. Who's deployed Kubernetes in production? Few less. Who enjoyed it? Oh, dudes, well done. There's a lot to it, right? There's a lot of infrastructure to support the infrastructure, right? Even just looking at the control plane that needs to be highly available and reliable and all those kind of good things. There's a bunch that needs to be done. Now, we can certainly reduce that burden, right? So managed Kubernetes services like Azure Kubernetes Service, they absolutely take care of that control plane problem for us. Don't need to worry about that. They give us some nodes, they take care of the hardware. We're good, right? Well, for development, if you're just playing around, absolutely. You could do this one little Azure CLI command, you're good to go. It's not really production ready though, is it? There's no kind of security on there. There's no way to manage apps. There's no way to do anything. That's okay. You can go over to the Azure Resource Center, and we've got really good guidance on all the decision points you now need to think about and make. Everything from which network stack are you going to use, how you're going to manage DevOps, how you're going to manage secrets. But this is Kubernetes. And the great thing about Kubernetes is there's lots of choice. And the worst thing about Kubernetes is there's lots of choice. So if we just take one of those decision points, how are we going to control traffic coming into our cluster? Well, here's some of the official options. And they all do the job. They're all awesome products. They're also all different. You know, it's not like it's choose this one or choose that one. They approach the problem differently. They're configured differently. They're managed differently. They use different language. All that kind of good stuff. So that's ingress, but when you think of all those other decision points you've got to make, there's a few other products you can go and look at. This is kind of the cloud native eye chart. So super powerful, super flexible. You can do it exactly what you want, but someone in your organization needs to take on that responsibility. Might be the dev team. In reality, it's probably an infrastructure team, because this is a whole world all of its own. But we go through all that, and we're good, right? Well, no, because that really doesn't give us a platform designed for microservices. The building blocks are all there, all right? So now you can go over to the Microsoft guidance on how to configure on top of your Kubernetes cluster to deploy microservices. So here's our reference architecture for doing that. There's a whole lot more there and decisions to be made, and that's awesome. Finally, we can deploy some code. So there's our code. But of course, because of the complexity of this and all the moving pieces, you know, there's cost associated with all the nodes that are controlling this and doing this. A lot of organizations go, that's awesome. We're going to deploy lots of apps into this. Now we need to figure out a way to keep those apps separate. We need to work out who to bill for those apps. So there's a whole lot of other complexity we've now introduced. And if you need that and you have the skills, fantastic. But you don't always. And we haven't still necessarily solved a lot of these problems. Again, we now have the building blocks to go and do those things, but as an app developer, how do I do that? Well, you go and learn about a lot of Kubernetes stuff, right? You go and learn about Helm charts, or if you're doing a GitOps approach, you do that. Lots and lots of different ways to do it. Wouldn't it be nicer if there was a simple way if we didn't need that level of control, right? And luckily for me at Build, Azure Container Apps finally went GA, which is awesome, and that's exactly what Container Apps is designed to do. It is a platform that's built on top of all the stuff we've already spoken about, right? So built on top of AKS and through that Kubernetes and all these other great open source products. But it's designed specifically for a pattern. It's designed to run microservices, right? So all that other stuff, the decisions around it are made for you, okay? This is like, you know, in a modern car, I open my hood, and luckily for me, because I know nothing about car engines, it's all black with a couple of little yellow bits where I should put things in. That's all I can do. If something breaks, I take it to someone who knows how to fix it. Now, for someone who's a car mechanic, that would drive them crazy. For me, that's awesome, because I just want to drive the car. Container Apps is kind of that for microservices. So what we're going to do today is look at two things. What Container Apps is, what it can do for you, what it can't do for you. But we're also going to drill in on Dapr, right? Because from a developer productivity tool, that's one of the other kind of new developments, I guess, in the last couple of years that can really change the game in terms of how we build portable microservices. So, what can we build? Well, microservices, but we can build different flavors of microservices, right? So we can build everything from your API web type traffic, but we can also build event-driven processing. You know, these days architectures are full of things arriving on queues or in storage containers or on all sorts of things that we need to react to. And back-end processing. So if we have something that kicks off on a timer, runs for a while and does something, we can do all those kind of things. So it's not just APIs. So how does it work? What kind of do we need to know about it? Well, the basic unit, or the basic thing we create, is called a Container Apps environment. Pretty creative name. All right? So this is our basic container. Oh, actually, that's a really bad word to use in this context. It's our thing into which we're going to run our microservice app. Naming things is hard. Okay, so an environment is an isolation boundary. It's contained in its own VNet. So that can be one that gets provisioned as part of the environment or an existing VNet you already have. Okay, and it provides that isolation boundary into which we're going to deploy our container apps. It shares a few other things. It shares a log analytics workspace, so all the logs go to the same thing. It's a little interesting to try and compare directly to Kubernetes concepts, because when I first saw this, I thought, think cluster. To me, this is actually closer, the way people use Kubernetes, because it can be very different, this is, to me, is closer to a namespace. Right? Typically in a Kubernetes cluster, if you're deploying an app, you'll probably get a namespace, and that's where you put your stuff, right? That's where security boundaries, like role-based access controls and network policies all kind of live. So it's kind of like that. So imagine there's no cluster, but there's a namespace powered by invisible cluster. All right, so then what do we do? So inside there, we deploy our container apps. So when you see container app, think microservice. All right, so each of our microservices is a container app. Now, just like in Kubernetes, you can have multiple containers that make up that microservice, but the idea here is they're supposed to be sidecar containers, right? It's not like you deploy 4 different microservices into one container app. They're going to be their own, each one of those is going to be their own thing, and they're all managed individually. And with each of those container apps, we get this concept of revisions. So every time you publish a container, a new build of your container app, it's immutable. So you're going to get a whole new revision. And we're going to see how that becomes really powerful later on. Especially when we, Yes, so we get our revisions. They keep getting deployed, and depending on how you configure it, there can be multiple of those active any one time. So that's going to help with our A/B testing and blue-green deployments and all those kind of things. Or you can just have one replace the other one and you're good to go. You can have up to 100, I think, inactive ones, so your old history can be there, and you don't get charged for the inactive ones. And as I mentioned, because it gives us a whole lot of functionality around ingress, we can use those revisions to do our traffic splitting. So as I said, blue-green deployments, A/B testing, whatever it happens to be, fast fallback, all those kind of things. So let's have a look and think about how would we deploy our Hello World container app. So we create our environment, which I've very creatively named sample environment. Okay. And when we provision an environment, one of the things we're not giving it is any concept of scale. It's just a bucket that container apps, all those kind of things about how much compute do we need are going to be at a container app level. So we have this thing we're going to deploy that into. And in our sample, we're going to deploy about the simplest microservice you can do. We're going to have just very simple Node front-end app and a .NET back-end app. Okay, so what would that look like if we were doing that from the Azure CLI? Pretty simple. Other than creating the resource group and things, this is the command here. So it's one command, and I guess the difference here is, unlike with the AKS cluster we deployed, we had to go and do all that extra steps once we deployed it. This is literally it. There are no more levers for you to pull other than what you see here. We're giving it a location, all good. As I said, not much actually in the environment. What we will get is a URI, something like this, where Azure Container Apps in a given region, and then it'll give our it'll give our environment a funky name. I don't know who wrote the new Microsoft stuff, but it gives you some interesting names. You can apply your own domains and everything. We'll see that in a bit. Where it gets more interesting is when we actually go to deploy a container app inside that. So again, there's not much to it, but it does have some key things, right? It's got what you'd expect, okay, which environment do we want, where's our container image located, and probably importantly at the bottom, what kind of ingress do you want? Is this something that's people are going to talk to from the outside, or is it purely internal to the environment? So this is our back-end app, so it's going to be internal. So we do that, and we get another URL subdomain of that environment. Pretty simple. Now we're going to deploy our front-end app, and you notice two things. One, the ingress for this one is external, right? And secondly, it needs to know how to find that other service it's going to talk to, because we haven't got to Dapr yet, which is going to help with that. So basically, we're going to keep track of that fully qualified domain name, and we're going to say, okay, here's the thing. Remember, it's an internal-only DNS, and that'll give us that, and away we go. So once we've done that, we can hit that crazy URL from the outside and get our wonderful sample app, which when we hit that button, calls to the back-end service, which returns a message to the front-end service to say, hello world. If we try and connect directly to the back-end microservice, it doesn't find it, because even though we gave it an FQDN, that's not resolvable in any DNS. Now, obviously that's done using the Azure CLI. In the real world, you would use your IAC of choice. Here's some bicep, does the same thing. And we're going to see in the next demo a bit more of an advanced one. So that's really all there is in terms of deploying an app. Okay, there is no more configuration to be done. There are no more choices. Under the hood, this is using Envoy as our ingress control and traffic splitting. If you want to use Nginx or any of those other cool ones, awesome. Go and do it on AKS. Container Apps does not expose and give you that customization, right? Container Apps is a very opinionated, under the hood way of how microservices should be run. What you deploy on top of that is entirely up to you. So there's no requirement for any particular base container image, any run stack you want, do whatever you like. For your app, we'll manage the service. That's the trade-off. Also has some other really cool things. So in terms of scaling, how you can scale, the usual types of things you'd expect and get in AKS, like CPU, memory usage, all those kind of good things. But because it has CADA built in, we also get all sorts of really interesting event-driven things. So queue lengths, number of HTTP requests, anything supported by the open source CADA project, not just Azure, it can be anything from Kafka queues to whatever you want to do. You can scale based on that as well. And what's really interesting in container apps is you can scale to 0. All right, so you can scale all the way down to 0. If you don't want any cold start time, like there's be a few seconds when you go back from 0 to 1, that's all right. You can set the minimum to 1. And if that 1 is running but it's not serving any traffic, it runs at a half price rate, so it's really cheap. So compared to what you would need to run as your resting rate, and this is particularly important if you're doing a high volume website or APIs, doesn't mean anything. But when you're thinking about, hey, we're doing these back-end processes, event-driven type things, that starts to get really cool, because all of a sudden you don't need to put everyone in the same bucket and then try and divide up the time they're using and try and separate them with a security. Give them their own container app, they pay for it, good to go. So that's container apps on its own, which is pretty cool. As a developer, I like that. I can just get going and start deploying my apps. When you combine it with Dapr though, I think that's when things get really interesting. Who's looked at Dapr, or using Dapr, knows what Dapr is? Only a couple of you? Oh, good. I had a really confusing conversation once, because those who are a little older might remember there was an ORM framework called Dapr. Yeah, and he was talking about that, and I was talking about this, and yeah, 15 minutes and a few wines, I was like, I understand it. So Dapr is the distributed application runtime. So just like container apps is really helping us with our kind of below-the-line part of microservice, right? That platform and workflow piece. Dapr is really about, on top of that, how can we build microservices more easily? How can we write an awful lot less code? How can we follow best practice? because I'm not sure, it's just us, we'll be fine. Not all microservice projects go well. Some of the best projects I've seen have been Kubernetes-based microservices. And some of the worst projects I've seen have been Kubernetes-based microservices. There's a lot to learn and a lot to get right. And things that look good on diagrams and start out really simply, when you get big and when you get complex, it becomes a multiplying effect, and it can be interesting. Interesting is probably the word I'm going to go with. So what Dapr is an open source set of APIs, really. It's completely language and platform agnostic. It can be adopted incrementally, so you don't need to go, well, we need to buy into Dapr, right? If you think of other things like who've been along this line, like Service Fabric, can be really productive, but you have to buy into that ecosystem. It's a whole way you architect and build and run your apps. Dapr can literally run on any hosting infrastructure and on your PC, and it provides these amazing, amazing stuff, particularly these building blocks, right? So this is the type of things you need to do in a microservice architecture. We're going to go and have a look at those. And the reason we're crossing over to this is Container Apps provides a fully managed Dapr service as part of its thing. So you don't need to do anything, you don't need to deploy anything. You just enable it and it's there. And this is what's going to help us with those same sort of challenges, but now in our code. All right? Particularly that bottom one. So when we use these different building blocks, like service-to-service invocation or state management, basically there's nothing in our code that relates to what the backing service is. We're going to see. So if you want to change from, say, using something like Redis to something like Cosmos DB or one of the AWS or Google services, you don't need to change your code. You just change a component configuration file, and you can redeploy it that way. So let's have a look at how that works. So we've deployed our containerized app in Container Apps, and because we've enabled, bit of echo there. Because we've enabled Dapr gets deployed using a sidecar. So it's a container that sits right alongside your container. And whenever you want to do anything in Dapr, your application is literally talking to that thing. Right? So you'll see when we get to the demo, it's always going to say localhost, which is really confusing the first time you see it. It just means it's literally in the same little environment. And then it has a set of APIs we can call to do the different things. You know, whether that's state management, publish, subscribe, or actually calling a service. Because if you remember back to Container Apps, we actually had to pass around that FQDN of the service. This is what's going to get rid of that. Cool, and the way it does that is this. So yes, we've got our container. Here's our service A, service B. They talk to their local sidecars. And then Dapr provides a whole lot of cool stuff, including multicast, DNS, and lookups, and all that kind of stuff. So we actually don't need to worry about that anymore. It'll go and find, in our Container Apps environment, where is service A, and it will find you and connect to it. But more than that, it'll also handle the problems we need to handle. What if it doesn't respond? Well, what do we do? Do we retry? Do we back off? What do we do? Those can be configured as policies, again, outside your app, so your code doesn't need to know how to deal with those services. Cool. And as I mentioned, one of my favorite parts is components, because it means in my code, I don't need to know how to talk to service bus. If I'm not doing anything beyond like the 80% of what most developers would do, I can just configure up a pub sub component and I can tell it to use service bus and I send a message. Same thing for state stores and observability, whatever you want to use for your observability platform. We externalize that from the app just like we did for identity. Instead of writing the create user table, we used Azure AD. We're doing the same thing here. So that means when we build our apps now, when our clever boss comes along tomorrow and said, I heard this service is now no good because, you know, reasons, and we should be using this service. Awesome, we can just quickly change that. Or if we're running this thing in Azure and now we want to run it in a different cloud or on-prem or on a laptop, or we're giving it to a customer and they don't use that particular service because it's not approved by cybersecurity because, you know, they don't approve things, that's not part of their role, we can quickly change that. Super, super easy, and we'll see how that goes. And the way that works is, it's a YAML file. Okay, we got away from Kubernetes. We can't get away from YAML. It's just, you just can't. But at least it's not horrendously painful. Basically, the top part are the same. So in this particular case, this is a state component. We just tell it, okay, give it a name. Okay, this is the corporate database. What type is it? Okay, it's Cosmos. And then underneath that, this stuff will change. You know, for Cosmos, it looks like this. For another service, it'll look like something else. But what's important is the stuff on the left. The URLs we're calling from our app do not change, doesn't matter. So if we want to change from Cosmos to Redis, we just change that to state.redis, some metadata, and nothing on the left changes. And this is a bit different if anyone's written Azure Functions. Azure Functions has a way of kind of dealing with this with our input-output bindings. You can see up here, so here we've got a binding to a blob and a service bus. But which is great because I don't need to in my main loop deal with that. But if I want to change from service bus to Redis, I've got to come and change code and test that. So it's actually in there still. So that's the advantage. So we're going to go through a slightly more involved example, but this time, as well as container apps, we're going to have a little Dapr as well and just kind of see what that looks like. So again, it's pretty simple though, still, the sample app. It's a few different languages and a few different runtimes just to keep life interesting. The first one is we're going to have a Node.js app. That's going to be our front-end app. And really all it's going to do is expose 3 endpoints. One for the Hello World test page, one for the inventory service at the back end, which is going to be written in Python, and one for the orders, which is written in Go, because you've got to have Go. It's like you've got to have YAML, you've got to have Go. Don't know why. But there's nothing special about these apps, right? The Docker file for the thing looks exactly like any other Docker file would look for this type of app, right? It's just using Alpine as its base image. There's no special requirements. There's nothing Dapr-y or container appsy in how we build our files. And this is going to become important later because we might go down this route and later on someone says, nope, we're going over to Kubernetes, we're going to pick up your app. There's nothing in here that ties this to container apps. Pick it up and run it. Or the other way, hey, we're running this in AKS, we think it could now run container apps. Pick it up and run it. Nothing special. I'm going to have to put my glasses on now. Okay, so how are we going to call that sidecar? Well, there's 2 ways to do it. You can literally just treat it like any other API you would use. Right, so in this particular case, it's building out the URL there. You can see it's talking to localhost, and it's passing in there, we want to talk to our inventory service. It's put that in there, and away you go. You can optionally as well, instead of putting the service in the URI, you can put it as a HTTP header. But this is the case where there's nothing fancy. We're just treating it like any other API. And this is why Dapr is great, because it means you can literally use any language that can make a HTTP call or a gRPC call. We can use it for that. If you want to, though, there is an SDK to make your life easier. So here's our Python service. It's including the Dapr client. And all it means is our name, now we have a thing that says get state and the name, rather than having to build that URL yourself. So you can use the SDK, whatever, but you don't need to. The very last thing we need to do is configure that component, which is the state store we spoke about. And really, the only thing we're doing here that's of interest is we're telling it the type, like what we saw. I'm giving it a name, this order's name, and that's what it's going to refer to. And I'm also scoping it to which container apps can access it. Because these components are actually defined at that environment level, so they can be shared. But you don't have to. You can scope it down so, hey, only the Python app can use this particular component. And how do you find out what all those magic settings are? Well, you go to the docs. Of course, we don't like to read docs, but they're all there on the Dapr site. It's pretty straightforward. You just pick whichever state store you want to use, and it gives you the, I'm sure we don't cut and paste, but we cut and paste. It's fine. Okay, we do all that. In this particular case, I'm using GitHub Actions, so I just push up that code. It does all its normal thing. It builds the 3 containers. I've also got some bicep code in there just to deploy the Azure resources we're going to need. And we end up with this, right? This is a set of resources in our little demo here. We've got API Management App Insights Cosmos, but I guess most importantly, we've got our Container Apps environment. And we can see here our apps are Azure objects. Azure knows about these apps. So that means all the good stuff around role-based access control and whatever we can apply at the container app level. If we drill in and go and have a look in the Azure portal at the environment, remember I said it doesn't actually have a lot of knobs and bells and levers and things? That's probably the saddest left-hand menu I've ever seen on an Azure service. I don't know if anyone's looked at things like APIM or App Service lately. The feature set that's built into that thing is enormous. This isn't that, and that's quite deliberate, right? Remember, we're managing that platform under the hood. This is going to get a lot more interesting when we get to the app level. But the two things, obviously, we do have here, we can see, as I mentioned, the Dapr components defined at the environment level. We can see what they are here, and probably importantly, our apps are here. So if we drill into our apps, we can see, okay, there's our Python, Go, and Node. Our Node was the front end. And now the left menu starts to get more interesting, because this is the stuff we care about. How are we actually going to control, scale, and manage our app? So you can see, just like before, we've got an application URL. Whether it's externally available or not, it will have one of these. It just won't resolve outside. We can see which environment it's in. And we can see all the good stuff we can do with it. Now, we did, for this particular one, we enabled ingress. So in theory, we should be able to hit it from the outside. And we also enabled Dapr in our configuration. So we can see there, yes, it's enabled, tells you what ports it's on, and all good to go. And you can see we can choose which protocol, HTTP, or if you want to be really cool, go gRPC. Doesn't matter. So once we do that, we hit our Node app, and we get this super exciting, slightly more colorful UI, because I invested heavily in this. And really, here's just some simple forms with those three different, three actions on two different endpoints we can see here. So if we, up the top here, we can create like a very simple order service. And yeah, obviously not quite so much time in the formatting of the response, but okay, it went off and it's telling us it created that thing via the state store. And if we go in and have a look at the Cosmos DB in our case, we can see that there's our Melbourne, there's our row. So it's gone through and done that, even though our code didn't have any knowledge of service bus, Cosmos. But because it was talking to Dapr and said, hey, Dapr, go and stick this in the state store, this is where it ended up. Pretty cool. If we wanted to come along and change that, without redeploying our app, we could change the definition of that component to point to table storage or Redis or wherever else we wanted to go, and we wouldn't need to change our code. So that's that kind of idea of components. Now, in terms of revisions and how we manage revisions, this is where we can see, as I've run this pipeline a few times, we can see here we've got multiple revisions of my one service. Luckily, everything's got a green tick. And you see on the right, though, over here, by default, these bottom two weren't active, because I basically said, hey, just replace it. So I've had to show this little show inactive one here. But you can see here now, I've got some simple traffic splitting. So I'm just doing it here through the portal, but you obviously could use, if this was part of your deployment process, you would use this as part of your CI/CD. So I go in through, I put 50% traffic. Anyone's done this in app service, it has the same idea with the slots. You can go and choose how much traffic goes to different slots. So that's really simple, but really powerful, right? Because that means I can now deploy my new version and give it 0 traffic. I can go and then add 5% of traffic, run it for an hour. If I don't get any errors and there's no negative feedback on Twitter, I can go 10%, 20%.
Will it be the same for PubSub? Or is it just for each?
So this is for traffic into the microservice. What that microservice does would then depend. So yeah, if it was using PubSub, then it could process messages. This is for HTTP traffic inbound. And this is our Envoy component at work here. No, good question. We can go in and look at every revision, because every revision of our app also contains, we can see there which containers are deployed. In this case, we're only specifying one, although they'll end up being 2 because we've got Dapr. But what's probably more interesting is all the scale setting and scale rules I spoke about. They're configured at a revision level. So for example, I might want to deploy a new revision with the same code, but with different configuration settings in terms of the scaling, so they can all scale independently. the revisions, not just the microservices themselves. And we can see here we've got min and max replicas. I could have had a whole lot of scale rules here around queue lengths or HTTP requests or any of those other good Kata stuff, and they can be different. Even though we can't get into kube control or anything like that, all the logs that come out of these containers, your standard error, all those kind of things, are logged to log analytics. But you can also come in, if you don't want to go and dig in log analytics, you can connect here and get a live log stream of all the different individual containers within a revision. So in this case here, I'm looking at my Python app, but because the Dapr container is there as well, I can jump over and look at whatever the heck the Dapr container is doing if I want to as well. So we can still get to the container logs, even though we don't get kube control. And out of the box, it comes pre-configured on container apps with App Insights. So we get all that kind of good tracing. You can see here it's aware of all the different microservices. We can see the traffic going to the different Dapr APIs, all those kind of good things, and we can drill in and look at response times and errors and all those kind of things we like to do with App Insights or whatever we're using for our observability. Cool. Just checking time. Good. Okay. So, let's go back to the beginning now, when we spoke about this. Because as I've been talking to, I've been doing this myself and talking to other people about where does this fit in? Why do we need another container service? Because there's already a lot of places on Azure you can run containers. Okay, we can run them in Kubernetes. We can run them in App Service. We can use Azure Container Instances, and they're all awesome, but they serve different parts. So why do we need another one? Well, if we were going to build, say, a static website, which is what this reference architecture was, right, with our content, our CDNs, our APIs to give us our dynamic things. This is a kind of the reference architecture we saw before, right? We can absolutely go and build this. We have to layer onto it all those kind of management and deployment and workflow stuff, but we can do that, and certainly I have done that. Or we could deploy Azure Static Web Apps, right? This is a service which is basically an opinionated implementation of that plus workflow, which solves this problem for you. So if your problem matches that problem, and you can live without the different low-level access, then this is way easier. You literally provision it, give it a couple of values, and you're up and running. So this is kind of analogous to what Azure Container Apps is. Okay, if you've got a microservice problem like this, right? Because what you can deploy on AKS and Kubernetes in general is phenomenally flexible. Like, I've got no stats, I'm completely making this number up. But I wouldn't be surprised if most of the things running in AKS is legacy stuff. Anyone want to violently disagree with me? I'm happy to be challenged. But, okay, let's go a lot, right? So instead of lifting and shifting to VMs, we lift and shift to Kubernetes in a lot of cases, right? And Kubernetes chews that up and can go on. Equally well, we can build from scratch absolutely wonderful modern stuff in Kubernetes, and that's awesome. But you do have to do that extra work. Well, let me rephrase that. Someone has to do that extra work. That might be developers, that might be an infrastructure team, or it might be a hybrid. But if you want to build these things from scratch, container apps is potentially a really interesting option. Because as you saw, literally you can have a production ready, not a hello world environment, ready with a very small piece of infrastructure as code script or however you want to do it, right? But at the same time, we've got all these good things with, we've got revisions, we've got all this kind of great stuff built on top. So as a developer, super productive, but also production ready, not because we're super clever, because we've made decisions and reduced the level of flexibility. That's a trade-off. So unfortunately, I'm pretty sure we're not going to be running Minecraft servers, which seems to be one of the go-to Microsoft things to do when you're teaching people Kubernetes, just to show that it doesn't need to be a web app. If you're building modern stuff, then this is pretty much a sweet spot. So I mentioned all the good places you can run containers in Azure, but I guess the containers are just part of it. So obviously, to support our wonderful microservice applications, we need a whole lot of really cool data stores. We need a whole lot of services we can talk to. So obviously they're all available in Azure. And what we're seeing now is things like Azure Arc coming in. Is everyone across Azure Arc or completely confused by Azure Arc? No? Okay. So Azure Arc is basically, okay, we're actually going to, especially with Kubernetes, we can deploy a Kubernetes cluster anywhere, on-prem in another cloud provider, and then extend the Azure control plane down to that. So whereas you might go into AKS or an Azure function or a web app and say, I want to deploy to Australia East, I want to deploy to Australia Southeast, there'll now be a third option, insert wherever you put your cluster here. So from your point of view, you can deploy a lot of the same services, use Azure policies, all those kind of good things. So all this stuff is built on a framework which is designed to give you that flexibility as well. Makes some really interesting conversations. Because just because you can do something, I don't know, in IT, and particularly when you're dev, doesn't mean you should. You know, putting your app, and I'm personalizing here because I've been having a lot of these conversations lately, where people want to put their web app in Cloud X, their database in Y, and their content in somewhere else. You can technically absolutely do that. Does anyone want to put up their hand to do that? No. Physics are still involved. Cool. All right. So I guess here was our goal, and the way I wanted to go through this content today is really focusing on these kind of 4 things. As developers, how do we do this, right? How do we reduce the complexity that we want to do? And I think, I hope as we've gone through that, you can see if you think about what each of those services had to do in terms of Dapr, in terms of container apps, there's certainly a lot less complexity on there. We don't need to layer on a whole lot of management. And I think to me, this is probably the key thing. Running containers in a simplified way is great. What this isn't, though, is an even more managed Kubernetes. Effectively, where we get to now is you deal as a developer with this concept of container environments and container apps, and you just forget that it's Kubernetes under the hood. It could be something else down the track. Who the heck knows, right? But as a developer, you don't care. But at the same time, if your company came along and said, hey, we love that app, but now we want to run it on this Kubernetes platform over here, you say, go for it. As long as you do all that management stuff, go for it. Your code literally doesn't change. So this combination, though, of container apps and Dapr is super powerful. But it's really important to call out, though, you don't need to use Dapr with container apps, and you don't need to use container apps to use Dapr. You can use them independently. There are now add-ons for AKS to manage that installation for you, just like there is for Kata. You can install the Kata autoscaler in the clusters. And I think we're going to see a lot more of this over the next little while, where things like container apps are going to provide that very opinionated, out-of-the-box, here you go type service. But at the same time, and in parallel, they're going to be doing things in AKS land to kind of reduce that burden of adopting these things. So I think you might have seen lately, there's been a lot of what they call these add-ons in AKS land, which is basically, hey, if you want to enable a Kata, say you tick a box, enable an add-on, we'll install that for you into the cluster, we'll configure it, and we'll maintain it for you. So it's kind of like the middle ground. So this is absolutely not designed to replace AKS or Kubernetes, however you run it, right? This is designed to be a parallel service where it makes sense. And that decision of does it make sense is going to be very, very individual. If you have a team that's geared up and skilled to look after Kubernetes, and you've got a big investment in Kubernetes, and you've got all that stuff figured out in terms of sharing costs and doing all that kind of thing, then this might not add a whole lot of value because you've already invested that time, you got the thing. On the other hand, there's probably a lot of cases where, hey, maybe where we need it, so if we're running some super duper high value IP middleware stuff we've developed, we should have that in our fully managed cluster because we can lock that down, we can do all kind of things. Or you've got really specific regulatory requirements, all those kind of things, then that's where something like AKS is great because that gives you all those options. But there's probably things running even in there, maybe that don't need to be in there. Maybe we can reduce the size of that cluster because you know what, our marketing website or our customer-facing APIs, or our partner-facing APIs, which, guess what, have to be exposed externally anyway, could take advantage of these services. And because the container apps can be deployed into your own VNets, they can run side by side. You can take advantage of all the good private link and all those kind of good things that you used to in Azure to securely connect to services. So that's Todd's opinion, by the way. There's a little I need a little asterisk in the air above me. That's where I see this stuff going. So if you want to learn more about this, I've got some simple links there. There is a great book for .NET developers, a free ebook around Dapr for .NET. It takes you through the whole bit. There's plenty of good stuff on the Dapr website and the Container Apps site on Microsoft. I hope that was useful. No one's running home to beat up their AKS administrators or anything like that. No, we all get along, he says, wearing a T-shirt. Yes, so that's all I want to cover. Is there any questions?
From upgrade to upgrade between like Kubernetes, how does that affect?
Really, really good thing. And I wrote that down and I forgot to say it because I was getting excited about something. One of the other challenges, one of the great things and the challenges for Kubernetes is how damn fast it moves, right? New versions all the time, and managed services like Kubernetes, there's only so far you can drift behind before you're not supported anymore and will force you to upgrade. And that is one of the challenges. And if I'll come back and find it, but you'll notice one of the things I didn't specify, or one of the things I did specify on my little one-liner to create the AKS cluster was the Kubernetes version. What I didn't specify when I created the container environment was the Kubernetes version. Right? So as I said, it's abstracted for you. It's a little bit like with Azure SQL DB. What version's it on? Right? Whereas if I deploy Azure SQL MI, managed instance, I can set a compatibility on a particular version that I want. This is kind of the same thing. So no, there is no Kubernetes upgrade that will be possible to you because remember, you're not dealing with Kubernetes constructs. All you're deploying is a container app. Now, there's obviously a mapping somewhere that maps that to, that would relate to some services and replica sets and daemon sets and who the heck knows what on the Kubernetes cluster. But you don't see that. That's managed for you. That's part of the, you lose all that control, but hey, on the plus side, you don't need to worry about that because, yeah, that's an interesting nightmare scenario is just that constant upgrading of the platform. That make sense?
Yeah. So when you, I've seen some organizations, they when they want to adapt microservices, they use Azure Functions. I think you already touched on.
Yep.
And then the other side of the thing is AKS, and they see which one should they take. Maybe they go with Azure Function because it's just managed option, as you said.
Yep.
Is container app is just something in between that it gives you still some flexibility, or it is good for orchestrating containers at the same time. It has got AKS underneath.
Yeah, that's a really good point.
And if that's the case, do you think
Where is it?
Is there any benefit for those people to move from functions to containers?
Yeah, it's really interesting because I love Azure Functions. I do a lot of stuff with Azure Functions, right? But I think as we saw there, and this is true of most functions. If you go to Lambda on AWS or whatever, one of the blockers and the reason I've seen for not using this is because people didn't want to be tied to a platform, right? So it's a little interesting with Azure Functions because Azure Functions is actually open source. So you can actually run Azure Functions on AWS or on your PC. But as a service on Azure, when you write for Azure Functions, as I said, you use these bindings, this is all tied. If you want to move to some other cloud and use some other service, you'd have to go and touch those codes. So I think you're right. I think container apps could be seen as a really interesting middle ground because it has that advantage of there's nothing in the container app. You're not creating a dependency on anything that links it to container app. You can literally take that container and run it anywhere. You have to do all the other stuff. So I think I think your point's really good that this could be, hey, we don't want to go to something like Azure Functions or anything that's platform specific, right? Azure Functions is a good example, but it could be other stuff. equally well, what I see a lot of people doing is and that's why on the that reference one, it had API management on the front, because that's the other common pattern I see. They put Azure API management on the front, and then, okay, they might even in parallel say, hey, we're going to deliver, this project is going to deliver these microservices using Azure Functions, because they're super simple, right? And you can see how little code you've got to write here to put into whatever. And then API can sit in front of those. You might have others that are deployed in Kubernetes and now in container apps that all sit behind that. And then anyone in your business who's consuming those services, they don't know that it's functions. They're not calling URL anything to do with functions. So you can move your implementation between those services, and APIM completely facades that. That's the other common pattern I see, particularly early on when things are new. People are evaluating these different things, or often the case, different projects just make different decisions. I love standards. There's so many of them. Right? Whenever I go and work with a customer, there's never one way of doing anything. So actually, I feel bad for saying this, but as a developer, APIM is now one of my favorite services. Because when people ask, should we do this or that, I go, well, whatever works for you, give it a try. We'll put APIM in front. We don't care. No one else will even know it happened. But I could definitely see that. I could see a few different patterns here. I could see people who've never done Kubernetes and don't want to adopt Kubernetes using this. I can also see people taking business units who are paying for a considerable amount to run their apps because of the overhead, pulling stuff out and putting into this as well. I'm having some conversations with customers about that now, because that whole chargeback thing gets really complicated inside a shared cluster, particularly when you're running all sorts of stuff just to keep the lights on. Because this thing, you can bill it individually. There's no overhead effectively for running it. You can scale to zero or near zero if you don't even want any startup time. It's pretty, from an economic, because I think that's potentially when we talk about serverless, we think of the tech, but the other half of serverless is the billing model. And sometimes we mean the billing model and sometimes we mean the tech. So I think that's where it gets some really interesting conversations. Any other questions? Yes.
Yeah, there was a mention about blue-green deployments. And given that the traffic splitting happens behind the ingress, I was just wondering how you control sending traffic to a particular revision. Is there header control or anything?
So that screen I showed, that was effectively going to go run off and configure Envoy to do the traffic splitting for you between the revisions.
Yeah, but if you're wanting to send traffic to the new revision for testing purposes.
Yep. Oh, okay. So can you use things other than, than just sending the traffic?
Because you've only got one ingress point, right? There's only one.
Yes. And in fact, I haven't checked it, because this only went GA. I actually started preparing this 3 months ago, and I'm going, please go GA, please go GA. And I need to check. I know, for example, in web apps, when you do this with slots, each slot actually gets its own URL as well.
Yeah.
So I actually don't know off the top of my head. I'll come back to you on that. I think what I'm wondering is there actually a specific URL? So if you wanted to do that scenario where, hey, I don't want you to split the traffic just randomly, I want to be able to get to that revision.
I was curious if you bring up an additional external
Yeah.
to run your test through.
Interesting. You'd have to have a look. I'll ask that. Track me down later and I'll find out for you. I know in web apps there's a way, I can think of a way to do it by doing it myself, but I don't want to do that. I want the service to do it. So.
Yeah, I didn't want to install a separate, a different version.
Yeah. Yep. Getcha. Yep. So you'd have your environments for environments, test, dev, prod, but then once you're in prod, it's that last scenario of, okay, now I want to do my smoke test on the new version before anyone else sees it. Yeah. Okay. I'll track that down. Sorry, I thought I saw any other questions? Nope. Awesome. Well, go forth and do it. It's really, really easy to get started with. It is GA now and it is in Australia, so that's always handy. Super easy to get started with, and enjoy.